Okay, for the next two examples, we'll reverse the process. That is, we'll start with a familiar curve and write a pair of equations to describe the curve. It's important to know that there will be lots of different ways one can do this. In example 2, we have a simple line segment with initial point 2, 4 and terminal point 5, -1. To orient myself, I'm just going to go ahead and sketch a graph for this curve. Initial point 2, 4, terminal point 5, -1. I have a line segment, and I'll use an arrow to indicate the direction of the curve. Now, one way to give a parametrization is by following theorem 1 on the second page of your reading. And the method I'll present is essentially the same, but the way I'll do it is hopefully a bit more memorable, that you won't have to depend on memorizing a formula. I'm going to start off by just introducing my initial point 2, 4, and then my terminal point 5, -1. And I'm going to give the dependence on t using a weighted average. So of course, if one is to average two tests, they would take 0.5 times the first test and 0.5 times the second test and add them up. And what's significant about those weights is that they're both positive and they add to 1. In the same way, I'm going to think of these coefficients 1 minus t and t as being weights. If t starts at 0 and goes to 1, then they'll both be positive and they'll add to 1. Now notice when t is equal to 0, then this first weight is 1, the second weight is 0, and I know that x is equal to 2. And similarly for y, when t is 0, I know that that's 1 and this is 0, so I know that y is equal to 4. Likewise, if I plug in t equal 1, I'll see that x is at 5 and y is at -1. So I can see how t equals 0 gives the initial point I want, and t equal 1 gives the terminal point that I want. Of course, I can simplify by multiplying out and collecting the coefficients of t. I'll see that x is equal to 2 plus 3t, y equals 4 minus 5t. Of course, my parameter interval is from 0 to 1. Okay. One last thing to consider is, why does this parametrization actually trace out a curve? Well, you'll see that the dependence of x on t is linear. So one could rewrite and say the dependence of t on x is linear, and then substitute into the second equation. You'll see that x and y depend linearly on one another, and therefore the curve really is the line segment.